Welcome back, everybody. Today I'll be doing AS Mathematics 9709. Today's topic is quadratic polynomials. I'd like to apologize for the quality of the PPT today. I had made notes on Microsoft OneNote, but I was unable to export it, so I've taken snapshots and made it into a form of a PPT. I hope the presentation is still clear and everyone understands what I will be trying to teach. All right, so let's get started. So today's focus is quadratic polynomials. A polynomial is basically a term in X. So a linear polynomial is ax plus c. It contains a term, ax, which has x raised to the power of 1, which is basically just x. Next up, we have quadratic polynomials, which is ax squared plus bx plus c. This is a usual form. It has a term which contains x to the power of 2, hence it's quadratic. It can also contain terms with the power of 1, but linear will only contain 1 or less. Quadratic will contain x raised to the power 2 or less, which is x raised to the power of 1 and x raised to the power of 0. Next up, we have a cubic polynomial. It's called cubic because it contains a term where x is raised to the power of 3. And then it can also contain x squared, x, and then x equals x raised to the power of 0, which is basically nothing. So a quadratic polynomial can have one solution, no solutions. So basically a solution is when the graphical representation of the polynomial cuts the x-axis, or when ax plus c is equated to 0. Okay. In this case, y equals to x squared, or it can be y equals to x squared plus x minus 6, which is a quadratic polynomial represented on the y and x-axis, cuts the x-axis at 2 points, which is x equals to 2 and x equals to minus 3. And these are the solutions. So for a linear graph, which is basically y equals to x plus 1, it will always have either 1 or no solutions. Any straight line will cut the x-axis regardless of the gradient. If it's a vertical line, it will cut the x-axis at 1 point. And if it's a horizontal line, it will not cut the x-axis, or it will have infinite solutions if it is the x-axis in this case. For quadratic polynomials, it can cut the x-axis, at 1 point, like in this representation, or it can cut at 2 points, or it can completely lie above the x-axis, or it can also completely lie below the x-axis, hence no solutions. It's the same thing for cubic polynomials, but we're not going to get into the graphical representation right now. So like I said, for finding the solution, you equate it to 0, or when it cuts the x-axis is when y equals to 0. So x plus 1 equals to 0, and then you can solve it for x equals to minus 1. And then for this quadratic equation, which is x squared plus x minus 6 equals to 0, if you punch this into your calculator, it will solve it directly, giving you x equals to 2 and x equals to minus 3. However, I would just like to go into the manual method because it's good to know how to solve quadratic equations by yourselves if you don't have the aid of a calculator. So take note of your quadratic equation. It's x squared plus x minus 6. You draw this grid, just these two lines. You put the coefficient of your x squared term over here. So in this case, it's 1. So it's x squared. And then you put the third term, the constant term over here, which is minus 6. And then you put this middle term, which is usually bx, as represented in this form, in the last column. So x squared, how do you form x squared? X squared is formed by x multiplied by x. So when you go down this column, it's multiplication. So x times x gives you x squared. And then minus 6 can be split into 3 and 2. So negative 2, sorry. So 3 times negative 2 gives you minus 6. It can be 6 and minus 1 as well. But in this case, we have to form this. You have to form this term over here. So let's just take it as 3 and minus 2 over here. And then you cross multiply. So it becomes x times negative 2 gives you negative 2x. X times 3 gives you 3x. And then when you go down the last column, it's addition, sorry. So 3x plus negative 2x gives you x. And then to form this, to convert this information into this form, you just add them together. So x plus 3 gives you x plus 3, x plus minus 2 gives you x minus 2. Now these terms, or basically it's been factorized, This can be solved. So x minus 2 equals to 0 gives you a negative. So you just bring the negative 2 across and you get x equals to 2. You bring the plus 3 across, you get minus 3. Like I said, solution is the point the graph cuts the x-axis. It's not supposed to be line. That was a mistake on my part. Next up, we have discriminant and number of solutions. So like I said, your quadratic equation is represented in this form. It can be factorized in these two forms. So it's x minus g multiplied by x minus h. This shows that you have two solutions. It can also be a repeated root, which is x minus e raised to the power 2. This means it has one solution. There's also a case where there's no solutions, but this is how it's factorized. To solve a quadratic equation, this is the formula for solving a quadratic equation. If it's not a nice number, in this case 2 and minus 3, it's usually this is the formula that you use if it cannot be factorized nicely. So x equals to negative b plus minus square root b squared minus 4ac, the whole thing divided by 2a. B, A and C are represented by these coefficients over here. So this plus minus represents basically when you square root a number, you can get a positive or a negative number. So we have one solution which is negative b, and b squared minus 4ac is positive. So it's plus b squared minus 4ac over 2a. Or you consider when b squared minus square root of b squared minus 4ac is a negative number. So negative b minus square root b squared minus 4ac over 2a. And these are the two solutions. One thing to take note, this graph is enlarged over here. This is the first coordinate, and this is the second coordinate. The line of symmetry lies between the two roots. You shall see it in this graph as well. I haven't really drawn it properly, but at any point, the midpoint of the two roots will give you the line of symmetry for a quadratic curve. So x1 plus x2 divided by 2 gives you the x coordinate or the line of symmetry that the line of symmetry that passes through this x coordinate. So how do you find the midpoint from this quadratic equation? So if you take negative b plus negative b plus square root b squared minus 4ac over 2a plus negative b minus b squared minus 4ac over 2a, you realize that the denominators are same, so you can add the numerators, and then plus b squared minus 4ac and minus b squared minus 4ac, they cancel out, so that you get negative b plus negative b over 2a, which gives you which is basically this term over here, and then you divide that by 2 to find the midpoint, and you get negative b over 2a. So there's two formulas that you should know. First of all, it's how to find, it's called a quadratic formula to find the solution of x, and then a formula in it's not really a formula, but basically you have derived it over here. The midpoint is basically negative b over 2a. Try to understand these formulas and not memorize them. The only thing you actually have to memorize is this quadratic formula. This midpoint formula that we have just derived, and it's easy. You just try to memorize it, or not memorize it. Try to understand what I've done by x plus x2 over divided by 2, which gives you negative b over 2a. So just use this derivation to understand your formulas. Next up, when b squared minus 4ac equals to 0, right? Just before we move on, b squared minus 4ac is known as a discriminant, right? And I'll explain this further. So you can, instead of doing this entire thing, you can test whether it will have one solution, two solutions, or no solutions. So that's what the discriminant is for. It's to test if the number of solutions, and that is b squared minus 4ac. When b squared minus 4ac equals to 0, it'll have repeated roots, and the graph will just touch the x-axis. It can be above, or it can also be below the x-axis. Then we have b squared minus 4ac, which is more than 0, which means there's two roots. It can be either this white graph or this red graph. It will always cut the x-axis at 2 points, over here and over here. Then we have b squared minus 4ac, which is less than 0. That means there's no roots. It will lie above the x-axis or below the x-axis as such. It doesn't touch the x-axis at all. Next up, we have understanding the discriminant. x equals to negative, looking at the quadratic formula, x equals to negative b plus minus b square minus 4ac over 2a. So negative b and 2a, which are underlined in white, they remain constant because they have fixed values. They are coefficients. They don't change. However, square root b square minus 4ac varies because it can have a positive or negative value. And also, you're square rooting it. So if b square minus 4ac is positive, square root of a positive number has two values. So square root of 4 can have 2 or minus 2. So it can either be x equals, and assuming b square minus 4ac is 4, so it'll be negative b plus 2 over 2a, or it'll be x equals to negative b minus 2 over 2a. That's how the discriminant works. However, if b squared minus 4ac equals to 0, this entire term equals to 0. So you have negative b plus minus 0. So negative b plus 0 is just same as negative b minus 0 because 0 has no value. So it has only one value. And then the other case is if b squared minus 4ac is less than 0. So if you punch in a square root of a negative number, you will get an error or you get an imaginary number in your calculator. And imaginary number is basically I, and I equals to square root of negative 1. This is not in the AS syllabus. You'll learn this in A2 next year. Basically, the root would not be visible on a real number axis. Thus, it doesn't appear to have any real roots. However, if you draw an axis that considers imaginary numbers, the graph will cut the x-axis. But right now, since you're only dealing with real numbers, sorry about that, it doesn't cut the x-axis.